So in that last lesson, we talked a lot about, how do we, or what is the rule, and we came up with square root of a times b equals just the product of the square roots. Right? When you the square root of a product is the same as the product of the square roots. So we can apply that now. Let's take some cases here. So this is square root of 4 is just 2 times the square root of 3, which is just 2 root 3. I know a lot of people are going to be tempted to type this in the calculator and write out some decimal. This is a number 2. This is a legitimate number. In fact, it's an exact answer, whereas your decimal is less exact. Square root of 100, 10, because 10 times 10 is 100. Square root of 36 is 6. So 10 times 6, 60. So always try to take your perfect squares and convert them to integers, and then write it next to the ones where you can't, because 2 root 3 is the same as 2 times the square root of 3. Similar to if I had 2x, it would be the same as 2 times x. All right, looking at the next one, square root of 3600. Well, if I type that in a calculator, I wonder if that comes out to be anything good. In fact, it is 60, because 60 times 60. And you'll notice there's maybe some pattern between 2 and 3. Does anyone notice anything? I mean, the answers are the same. Why are they the same? All right, this appears like, okay, well, 100 times 36 is 3600, which takes us back to this, right? The square root of 100, if a were 100 and b were 36, that would be exactly this. That number 2 is equal to number 3 is what this identity is telling us. So we can apply that going forward here. We have the square root of x squared times x squared, which I can just break up as the square root of x squared times the square root of x squared, which is the square root of a squared number is just the number itself. So x times x, which is x squared. So when you have something multiplied times itself inside the square root, in essence, one of them comes out, one of them goes away. More clearly, this is saying, what times itself can I then take the square root of to get x squared? This could also be rewritten as x squared squared. Right? So then the square root and the outside square would cancel. They would invert each other and then leaving you x squared. So this one, perfect squares. Think perfect squares. What perfect squares can I pull out? Well, I know x squared is a perfect square, which turns into x squared, and x squared, right? Because x squared times itself 3 times is x to the 6th. We learned from our power rules. If you need to see it written out, this is x squared to the 3rd, all square rooted. Which is just that, and each of these is x, so I have x, which is x cubed. Number 6, square root of 64 is 8. Square root of 2 is just square root of 2. 8 root 2. And I also know 64 times 2 is 128, and I notice 128 in here. So this has to be the same, 8 square root of 2. And the way I could do that is to break this up into the largest perfect square that goes into it, which in this case is square root of 64. So you should always be trying to break it up into perfect squares, because then that allows you to simplify it by taking things out of the radical. Here you can think of this as square root of 64 times square root of 36 times square root of 25 times square root of 16, which is just 8 times 6 times 5 times 4, which is, let's see, this is 20, 120, 120 times 8 is 960. I believe. Let me make sure that's true. 960. Okay. And then this last one, okay, again, the key thing to think about is what's the largest square root I can think of that I can take out of it. So the perfect squares, we can list them again. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and on and on and on. So one thing to think about is maybe trying to take the larger ones and divide 576 by that number to see if it goes in. So 576 divided by 121. I get a decimal, which means it doesn't go in evenly. I know 100 doesn't work. What about 81? 576 divided by 81. Nope. What about 64? 576 divided by 64 goes in 9 times. So I know this is the square root of 64 times the square root of 9, which is just 8 times 3, or 24. And if I type in square root of 576 in a calculator, I in fact get 24. So this is going to lead us then to simplifying radicals. And once we get to that, we're always going to leave them in simplified form, which means pulling items out of the square root. So no longer is square root of 128 an acceptable answer. I would expect you to write that as 8 square root of 2.